Hello, my friends. Welcome to a lesson exploring fractions with operations. Yeah, today we're going to explore some addition with fractions, and this one will have the like denominators. And just a refresher on those numerators and denominators. Remember, when we have a fraction, like this one, we've got those two numbers we can write, one right over the other. And that top one is the numerator. It tells us how many pieces we have. See, we've just got that one piece. The denominator, that bottom number, tells us how many pieces we would have if we had the whole. But I only have one of two. Pretty cool. Why don't we start our first problem with this one, actually? That would be a great option for us. So let's write out our problem. Let's say we've got 1/2, and let's add another half to that. And what does that equal? Yeah, I know, this is a pretty good one to start off with, though, right? Let's put that other half in there, and there we go. How cool is that? What do we have now? Yeah, 2 halves. But you know, that looks like something else. And I bet if you've done enough equivalence work, you'd be able to make that roundabout connection. Check it out. That's a whole. We could also write this as a nice big 1. It's one whole. It's pretty cool. And even if we had 3/3 or 4/4 or 5/5 or 700/700, we would still have that one whole. All right, let's try another one. Okay, what's a good one that you might like? Oh yeah, how about 2/5? There's our 2/5. Boop. Okay. And you know, if you've printed out your own pieces, that's fantastic. You can get a real good feeling for how this works. So let's write down our 2/5, because our 2 tells us we've got 2, and our 5 tells us how many we would have if we had the whole caboodle. Let's add 1/5 to that. So same denominator. Let's get our 1/5 out. There it is, and look at that. I bet you can already see the answer thanks to these materials. 1, 2, and 3/5. How fantastic. You're saying this is super easy. Yeah, well, what if we had one that, we didn't have a piece for? Ooh, that might be sort of difficult. Let's try that, though, anyway. What if we had, I don't know, 17ths? 3 of them. I know, they're sort of annoying, right? And why don't we add another annoying thing to it, like, I don't know, how about 7/17? It's almost hard to say, too. Yikes, what were they thinking? So, have you sort of figured out the pattern here yet? Maybe it'll take some time working with the materials. I don't have any 17ths here, but these are both 17ths. We could almost think like, well, these are both apples, or they're both bowling balls, or they're both dogs. If we have 3 dogs and 7 dogs and we add them together, exactly. Whether we have 17ths, dogs, donuts, or dolphins, we now have 10. And for this case, 10/17. But let me show you one more really cool trick. And this goes back to your whole idea of equivalence. So let's do something like 2/6 plus 1/6. And you might have already figured out that answer, but let me just put those materials out. Here's our 2/6. There's our other 6th, and we add them together. And then, well, remember my first example, how I made that whole? It's pretty cool, right? I bet you see that this one, now together, looks like something else you've seen. And, we could still write down that number, 1, 2, and 3/6. But this is equal to something else as well. If you've been doing plenty of that equivalence work, you saw that 1/2. 3/6 is equal to 1/2. And so either of those answers would suffice. But normally it's easy to look at something when it's all together like that half. So it's a good idea to reduce your fractions if you can to their lowest value. It's pretty amazing, and I hope you enjoyed this lesson. I'll see you again soon for some subtraction.